Okay, so now we're going to go for the next demo. So to another old hand in this industry and also in the DISC collaboration, been with us from the very start. We will have a presentation from Siemens. To move towards a fully digital and connected future for process engineering, we need a standardized way to share and use data. And in Siemens' presentation, they will focus on 3 focus areas. Import of simulation data to automatically generate process flow diagrams and convert them into a functional aspect integrated modeling framework. Number 2, exchange of product data with platforms like EQHub and Asset Administration Shell, ensuring consistent and structured information for equipment and assets. Number 3, use of cloud AI services to turn paper-based P&IDs and DEXP digital format, making all documents usable in a modern engineering tools. And this will be demonstrated and presented by Sigmund Broya and Emir Mustafik. Big applause.
Just give us a minute to set it up.
Mouse is important.
Yes, definitely.
Okay.
There we go. And we should be up and...
Yeah, good morning all together. Nice to be here again today, maybe with some more minutes time. When the technique is working, we will show you also our agenda.
We have presentation shyness as well from the equipment as well, so guess no mouse.
No mouse, okay.
Let me try the other one. Oh, that one.
Wait a moment.
Guess.
I think you need... I don't know.
No, it's fine. We do it without. That's fair.
I don't take it. No.
Good. Thank you very much. And thank you for a nice presentation. I'm Emir, and this is my colleague Sigi, and I'm going to start off with the presentation from the Siemens side. Here is our agenda for today. Whoop, there we go. So I'm going to start talking about how we consume the provided simulation data and the steps we took to get into to extract PFDs, master equipment list, as mentioned before, and convert those into IMF types. And later I'm going to continue talking about the steps we had to take in order to get to the point where we can do some product data exchange with EQHub. Then my colleague is going to come in and talk a little bit about other possibilities to handle product catalogs. And at the end, he's going to talk about what happens, how do we handle engineering data when it doesn't come or start coming in the form of simulation data, but actual P&IDs in the PDF format. Moving on, the platform that is chosen to do this as enabler for our presentation is called Comos. This is just a very quick, short presentation for those that might not know it. It's the Siemens engineering tool, and we provide a variety of applications within our portfolio, all the way from the beginning of the engineering phase, from process automations over into operations lifecycle. And we, of course, also have an engineering co-pilot to assist across our portfolio. Moving on to speak about what I'm going to present, I'm going to start with heat and mass balance files that have been provided so generously by the DISC team. We're going to grab this data, we're going to import it into Comos, crunch the data, and arrive at a PFD, which then we can also extract the master equipment list. We're going to also show afterwards how we convert those into IMF types, where we can export those and perhaps even share with the other customers. Then I am going to talk a little bit about the steps I'm going to take from converting a PFD into a PNID, where we have the actual equipment that can be purchased. And then I will showcase our interface towards the EQ Hub. So let's get straight into it. We start off with the heat and mass balance files. Here's an example of it in the JSON format, as the previous suggested. Here we have the 4 simulation cases, and each case has the pure components, streams, and the equipment defined with their respective data, plus the connectivity between all the equipment. What did not come with these files is the graphical information and relation between these equipment. Luckily for us, they also provided a screen picture from the Unisim software used to extract this information, and we used this data also to map the values over to Comus, import the data inside Comus, and using our field module, the result is a corresponding PFD. Now, let's get into Comus and see how that actually looks. So here is, whoops, why can we see it? Yeah, there we go, there it is. So this is how it actually, the representation of the simulation data looks inside Comus with one of the use cases. And I can show you here that we have all the data present. So here is a stream, and stream also contains, again, Comus representation of all the information from the simulation files. And we'll of course have the pure components for the specific cases just below, and those also have some information gathered from the stream. And of course, we do have imported the Comus representation of the equipment in the simulation files. Now that we have the data inside Comus, there is a relatively easy step to query this data and present them into certain files formats. So, for example, here is a material stream list that can be shown with all the necessary imported data. And I won't bore you for those who know it. And of course, we can also provide a master equipment list or the Comus version of it, where all the equipment shown in the simulation are shown in there and presented in certain shapes. Once again, we also have a relatively short time. We would really like to show you much more, but we need to continue on with the presentation. The next part is, now that we have all this information inside Comus, what happens if we want to share it, or what happens if there's another customer or sub-supplier where you would like to extract this data? And this is where possible IMF types definitions come in. So we developed a tool that will extract the IMF types from the Comus objects that we have imported. So here is an example. I can take this LP compressor and do the conversion. I can store it in the turtle format, in a turtle file. And I can do another one. I can perhaps, there we go, sorry. We also have some shyness. Hello. We also have some shyness. There we go. I don't want to copy you. I would like to drag and drop you and start the conversion. I can grab these two just for example, and then we can go in and show the representation of those. So here there's those two that I just exported, and we can start with this one, and here is the representation of it. What we did, we added a little bit information because in the original mass and balance files there weren't any graphical representation. So here we took our liberty and added the X and Y coordinates. So what we mean by this is if we export all the objects that we have imported from the mass files, we can package them in and send them to another company, and they will be able to reproduce what we have in Comus, at least graphically, with the simulation data. And again, this applies to, I don't know what this is, but we can of course go in and check, and this is rated power reference from the IMF model. Moving on, because time is relatively short. So now that we have a PFD inside Comus, the next natural step would be to, in the engineering process, is to generate a PNID from it, so we can start moving on. The way we do this is we can also have Comus help with that. So what I'm going to do is I'm going to generate an empty PNID, and I'm going to ask Comus to do this for me. So this is our empty PNID, and I'm going to take our PFD and drag and drop it inside the PNID and start the conversion. And I'll talk a little bit about the conversion because this is a bit of a lengthy process. The way we do this conversion is that we have predefined templates attached to every single equipment on the PFD, and the Comus goes in automatically, converts our PFD, generates all the objects that are relevant to a PNID, all the instruments, all the valves, etc., and we'll replace it. This is not a really real-time, not a real-world application, because usually you will have multiple PNIDs converted from a PFD. But this is a good starting point to have all the equipment in there, and then you can segment the resulting master PNID into your PNIDs or your section PNIDs the way you want them. Once again, this is not a fire and forget solution. There will always be a slight necessity to modify the result. As you will see in a second, it tries to avoid collision between the objects, as you can see here in the middle, by turning this template around, and as you will see, it drew some pipes where aesthetically is not pleasing, so certain modifications are needed. So for example, I would move this pipe or this one in order for it to look presentable. But we have some effort that is not needed to be done by the actual engineers by this automatic conversion. And then now we can cut and paste into your product breakdown structure, your PNIDs that you will need from this position. Moving on, now that we actually have a PNID, let's assume, and now that we actually have, yes, I understood, no worries, we are almost done. I'm going to showcase, did I double click? We still have the, presentation shyness, as usual. Oh, there we go. So I'm just going to quickly showcase the interface between EQ Hub. The EQ Hub guys have been so nice to provide some endpoints. This is the metadata presentation of a Comus object, and here we would like to have Comus guide the user with regards to the product data applied from the EQ Hub. So here I specified that it should only show the Siemens possible valves from the EQ Hub because we are Siemens, but it can be selecting one of these and importing the data will transfer the information from EQ Hub directly into Comus. Should this not be satisfactory, the suggested results we have developed as dedicated EQ Hub interface where the user can go in and, let's just say, search for all the valves, browse around, let's assume this one is the one, then we can do a specific search where we can take a look at the information, browsing the EQ Hub, and we can grab. But that's enough for me, because the time is short, and we're a little bit, so I'm giving the word.
Okay, thank you, Emir. Okay, next topic on our agenda. Let's start it. It's very small.
And then we just go a couple down.
Okay.
One more. There we go.
Okay. Yeah. Let's go on with the next topic. We saw EQ Hub. I know that you love EQHub. And yeah, I was not really sure if we also should pitch our approach in the direction of asset administration shell. But I saw yesterday also a love story between EQHub and asset administration shell. Also this wonderful presentation from Phoenix Contact. And indeed, we started also something together with our Team Center colleagues regarding EQ, regarding the asset administration shell product data exchange. And you are all from energy, oil and gas, and so on. And you know I know your big process plants, sometimes more than 100,000 tags. And it's always a challenge. Maybe some of them, a lot of equipment must be engineered, but there are also a lot of that you have to select from catalogs. Yeah? And this search, identification, is this the right one? Then maybe transforming this information into your engineering system, into the project handover, and so on. It's massive effort that is needed. We have a lot of interviews with customers, and the effort, and it's not from me, it's not from Siemens, it's from our customers, can be reduced with AIS technology by approximately 60%. Maybe I was not sure if for everybody it's clear, but for our use case, for the product data exchange, asset administration shell is delivering a lot of submodels. I think more than 100. But for our specific use case, only a few of them to describe, let's say, the product data of a device are very important. That means we are concentrating on the digital nameplate and the document handover. And behind these submodels, there are already standards that are used in the industry. And then we have the carbon footprint and, of course, technical data. Here we are using E-class and, if available, E-class 14. Yeah, on one hand, we have the supplier side. That means, for example, a supplier who is designing a product, maybe is using Team Center for the product design of a small part, and he is creating some product information, 3D model. Then he wants to publish this 3D model in his product catalog. Yeah? Here, maybe an AIS server. And on the other hand, we have also maybe OEMs who are designing bigger products, but using maybe products also for the design of their product from other suppliers. That means they need also somehow an access to this product data. And of course, we have the process plant, where we are using a lot of, let's say, modules from the OEMs, yeah, and products. And for the plant design, we need also exchange to this kind of product data. And what we are doing, we have in the middle our data exchange service. That is a service application. And we can connect this service application to any AIS server of any supplier. That means from Comos or from Team Center, we are starting our search by keywords, by indexing or something like that. And we are pushing it to the exchange service. And the exchange service is running then through all asset administration servers that are available. We are getting back the information, and we can choose the right device that is fulfilling our requirements. And of course, like I said, you see we are focusing on the digital nameplate, technical data, handover documentation, carbon footprint, but there are also a lot of interesting submodels that we have already on the roadmap. Yeah? What is also nice, we heard it yesterday also, are the product change notification. It's always a challenge to be informed when a product is changing. And that is this service, asset administration shell, is bringing out of the box. For Comos, here is it takes us maybe 4-6 weeks Unfortunately, I cannot show a live demo, but a first presentation how it would look like. On Coma's side, we will have a search. On the left side, you can put in some keywords, and then this search service will start to run. We will get an asset list of everything that is fulfilling the requirements. You can view inside. You can check the technical details. And then, of course, you can also select what is necessary for my project. Huh? Do I need only the nameplate? Do I need only the technical data? Or everything what is available? And then it will be downloaded to a download list. And then we are transferring this data to master objects in the master catalog of Comos. Okay, now the time is yellow already. Okay. Good, so far to the asset administration shell. Another interesting topic that we are working on is our iPit solution. It's a development name at the moment. Maybe we will create a more fancy one. Yeah, we spoke also yesterday about that. I think the challenges between greenfield and brownfield are really same. It's data exchange, it's data handover. Yeah? That means if an owner-operator is working together with an EPC for a brownfield project, then is, of course, let's say the handover is very often based on PDFs, PDF files. Conversion is needed, manual effort, and so on. And we have customers that build up really digital solutions, not only with Comos, with 3D system, hosted on not Siemens platforms, clouds, offering to their owner-operators, to the product owners. Of course, it costs a little bit money, but the decision is always, no, we take the PDF files. Yeah? And then it's starting somehow how to make these documents usable for my projects. And we decided to create a very generic way. That means based on these PDFs, we are developing this iPit AI service for the recognition of this, here in this case, PIN-IDs. I think a very important factor is the validation tool. That means we need your domain expertise. Yeah? Then the AI can learn. That means your experts that know how the PIN-ID, how the end result should look like, needs to be in the loop, and the quality will be later better and better. And then we are creating an DXP file out of it, and it can be reused in any application. We in our division, we have, for example, with gProms a simulation tool. Then if we have a DXP file, we can create out of this DXP file very easy simulation diagram, for example, for some online simulations in gProms. That means there are a lot of use cases where you can reuse the DXP file. Okay, going to the live demo, I will speed up.
You can have 1 more minute.
One more? Okay. Then I will hurry. Give me 2, then it's okay. Okay. Yeah, this application is running somewhere in a Siemens cloud, and I selected one project. We have also some customer examples. I cannot show them, but that is here a PIN-ID out of our process automation world in Karlsruhe, where we did where we exported a PDF. And here we did already the run through the AI. That means I can select everything that is already identified. I can also navigate to the identified components, for example. Oh, no, that's here. Okay. And 1 minute more. what is really important here? Yeah? I said what is really recognized. You see the probability, for example, and I have here a very nice example regarding for example this one here.
Yeah, it's difficult without a mouse. Yeah.
Yeah, it's very difficult without the mouse, but I think
without mouse it's really difficult. Okay,
need to close up.
I can
and
submit.
Impressive to do this without a mouse.
The result in the end.
Please visit Siemens up at their booth, and you will have a follow-up.
I will show you the result. Okay,
But now,
if anybody wants to see more,
yeah,
just speak with us.
come to the
yeah?
booth. Thank you.
Okay.
Yes, again, impressive to do that without a mouse. So, yes,
Yeah,
given a
it's
couple of extra
difficult.
minutes there. Thank you so much,
Thank you.
Siemens. Comments from the technical committee? You could just stand
Yes, thank you very much. My name is Jon Grevstad Theodosen, so I'm also part of PCA board and part of the technical committee today. Thank you very much, Sigmund and Emir, for your good presentation. It's really interesting to see what you've done with the PFDs, the MEL, also your live conversion of PFD to PNID. I think that one is good to see. Also, what you're doing towards EcoHub and asset administration shell. And it's also good to see it's not only Oikotech, but you also experienced the demo demon as well. Thank you again.
Thank you.
Thank you.